Hello, welcome to ANS Solver. This is the 10th question of the paper. So as you can see, they have told us that u is denoted by root 3 plus I. Okay, so we need to express u in the r into e raised to I theta form. Okay, so now I know that r into e raised to I theta, okay, this is called as the Euler polar form, where I know my r basically means my modulus, okay, my mod, theta is my argument. Okay, this is what I know. Now what I need to do is, first I need to express u in this form. So now first I'll calculate my modulus. So my modulus is basically given by the square root of the real part square plus the imaginary part square. So the real part is root 3 and the imaginary part is 1. So this is basically the root of 3 plus 1, which is basically the root of 4, which is 2. Okay, so this is the modulus. This I know is r. Now I need to calculate my argument. Okay, so now for the argument, I know that there's a small triangle here which I can make for my reference. Let theta be the argument here. Okay, and now I can say that the imaginary part, which is the vertical line, is basically 1 and root 3 is the baseline. So now I know tan theta is equal to the opposite over the adjacent. So it's tan theta over 1 over root 3. So theta is basically equal to tan inverse of 1 over root 3, which when calculation in the radian mode I get 1 over 6 pi. So now I have my theta also with me, I have my r with me. So I can write this basically as u equals to the 2 e raised to I into 1 over 6 pi. So I have written u in the Euler or polar form. Okay, so now what I need to do is the second part of the question, which states that the modulus argument of u raised to 4. So basically, if I know u is this, u raised to 4 will be equal to 2 e raised to I into 1 upon 6 pi raised to 4, which can be written as 2 raised to 4 into e raised to I into 1 over 6 pi into 4, because when it's raised to 4 it basically becomes into in the power. So I'll get 16 here, okay, into e raised to 1 upon 6 into 4 is basically 2 upon 3. So 2 over 3 pi, from which I can state that my modulus is 16 and the argument I have is 2 over 3 pi. This is what I can state. Okay, so they have asked us to write the modulus and argument values. So this is what I have stated. Okay, yeah. Yes, so this is the second part of the question. So I need to verify that u is a root of the equation z cube minus 8z plus 8 root 3. So that means whenever I put a root in the place of z here, the value I should get is 0. So what I'll simply do is I'll write this as root 3 plus I the whole cube minus 8 into root 3 plus I plus 8 root 3. Now when I solve this and get my answer 0, I can verify that u is a root. So now I can write this as root 3 plus I square into root 3 plus I, and here I can expand this and write this as minus 8 root 3 minus 8i plus 8 root 3. So now I can write this as a square plus b square, okay, plus 2 into a into b, correct, because this is a plus b the whole square, multiplied by root 3 plus I. Okay, now if you see minus 8 root 3 and 8 root 3 is getting cancelled, which is 0, so I get minus 8i only. Now I need to know that I know is root of minus 1. So I square will basically be minus 1, correct? Because root minus 1 into root minus 1, correct? So now I can basically write this as 3. I know I square is minus 1 plus 2 root 3i into root 3 plus I minus 8i. So I can write this as 2 plus 2 root 3i into root 3 plus I minus 8i. Now I can write this as 2 into root 3 plus I plus 2 root 3i into root 3 plus I minus 8i. So I can take 2 inside the bracket to get 2 root 3 plus 2i plus, when I take 2 root 3 inside the bracket, root 3 into root 3 will be 3. So I get 2 into 3i, and now when I take this here, I get 2 root 3 I square minus 8i. So now what I can simply do is I can write this as 2 root 3 plus 2i plus 6i, okay? And I have I square I know is minus 1, so this is minus 2 root 3 minus 8i. So I can simply cancel this out, and 6i plus 2i gives me 8i minus 8i, which is equal to 0. So it's verified that u is a root. Now I need to state another complex root of this equation. So you need to know when they give you an imaginary root here of root 3 plus I, the other root is basically the conjugate of this root. So the conjugate of the root you have, which is basically root 3 minus I, because in the conjugate only the sign for the imaginary portion changes. So this is basically your other root. Yeah. Now the third part. On a sketch of an Argand diagram, shade the region whose points represent the complex number z satisfying the inequality, okay, and the imaginary part. Now see, you know your u, okay, is simply root 3 plus I, correct, which has the coordinates of basically root 3 comma 1, correct, because 1 in the imaginary, root 3 in the real. Okay, so now I can say root 3, because z basically means 0, correct, or basically this is a form, okay. So I have root 3 here and I have 1 here, okay. So I know, let's say my point lies somewhere here. This is the center of the circle and it has a radius of 2 here. So radius of 2 basically means this is 2, this is 3, okay. Root 3 means this is, okay, 2 root 3, okay. This is basically 3 root 3, I can say, okay. This is what I have here, and basically something like this here, 1 and 2, okay, and I have something here. Just make a sketch, you don't need to be totally accurate. So now I have a circle here, okay, sorry, a circle. So basically a rough circle, okay. Now I know my imaginary should be more than 2. So my imaginary basically means a straight line which passes through 2. Okay. Now see, we need to satisfy the equations. I know my circle here needs to be less than 2. That means it's pointing inwards. My imaginary needs to be more than 2. That means it's pointing outwards. So the point which I have in common is basically this, which is basically satisfying the inequalities. Okay, so simple question. It's easy to understand. So yeah.